I'm Anil Kumar, and in this video we will explore existence of derivatives. The question is, provide examples in which derivative does not exist at x equals to 2. So I'll provide you with a lot of examples, but first let us try to understand why a derivative may not exist. So the question is, why derivative may not exist. Right, so that is the first question. You can pause the video, write down or list out reasons for that. Right, that would be a good exercise. Let's list down. I don't know how many reasons we are going to give, but let's try to figure out some. So one reason could be we have a vertical asymptote, right? So we have a vertical asymptote that could be a point, or I mean x equals to that line or x equals to that value, which will not be differentiable, right? So vertical asymptote. The other point could be whole, right? As you can see, these are the points which are not in the domain, correct? Or so these points may not be in the domain of the function, and therefore you cannot have derivative at that point. That is one reason. And then we could have discontinuity, kind of jump discontinuity. Now function can be defined at this point, but still the derivative may not exist, jump discontinuity. And the other examples are, we could have a corner, right? Or we could have a cusp. So I could have written both together, cusp or corner. And okay, or we could have, the last thing which we could have is a vertical tangent. Vertical tangent. So these could be different reasons of a function not having derivative at a particular point. Now the question here is that we want to give examples where derivative does not exist at 2. So that means at 2 we'll provide examples for each reason. So let me make some small graphs here. 3 and 3, 6. So let me make 6. Okay. And you also make these graphs, or you could also write equations, right? So we could also write equations. That's another thing which we could do. So vertical asymptote at 2. That means, let me draw one vertical asymptote here. So that is the vertical asymptote. And now let me sketch the function here. It could be like 1 over x function, right? Kind of like this. Okay. So this graph where we have a vertical asymptote at 2 is not differentiable at 2. Whole at 2, right? So if I'm looking for a whole at 2, so that means, let us say this is 2 for us, so there is a whole here. And if I have a function which is kind of like this, so I'm making a very simple examples, right? But you get an idea that this function is whole is at 2, so that point is not in the domain of the function. How can you make a tangent there? That is the whole thing, right? Jump discontinuity at 2. So jump discontinuity at 2 could be, we could have a step function here, or let us say, okay, let this be the function, and let me fill this up here. And so the function has a value at 2, however, you cannot draw a tangent at 2, right? So the limit does not exist at 2. So that is jump discontinuity, as you can see. Then corner at 2. So a good example could be absolute function which has been shifted 2 units to the right, correct? So that could be a good example for corner at 2. You get the point, correct? So that is at 2. Cusp at 2. So there are functions which are kind of like this, right? So kind of like this. So that is, you could have to the x to the power of 2 over 3, right? So that could be a function. And yeah, so at 2 we could have cusp, right? It is not necessary that this is x-intercept. I mean, it could be anywhere, correct? But at 2, right? Vertical tangent at 2. So vertical tangent are the functions where the function will be having kind of, cube root function, right? So like this. Do you see that? So when we do like this, then let us say this point is 2 for us. So we have a vertical tangent here at 2. So this is at 2. So these are a few very good examples where you could say that the tangent does not exist, right? Other points which just came in my mind to share with you were boundary conditions, right? So there could be some boundary conditions where at the boundary you may not be able to make a tangent, right? So boundary could be a good examples. Let me give you two examples here for boundary also, right? So one is square root function. For example, if I have a square root function which is kind of translated 2 units to the right. So that could be you. If you want to draw a tangent at this point, you cannot, right? So that could be a function for you. Now this one I've left for you to do. So one example is for you to do, right? So this is the question for you. So give me one more example, one more sketch of a function. Well, you could go a similar one which we have given, but I hope with this you get list of examples or conditions where derivative may not exist. Remember, all these functions you could have written in equation form also. For example, you could write y equals to square root of x minus 2. You could do y equals to 1 over x minus 2, right, for this particular function. You could do y equals to absolute value of x minus 2, correct? So likewise, you could do many different values, correct? So you could write down equations where the function may not have derivative at x equals to 2. I hope that helps. Thank you and all the best.